Hello, today our topic of discussion is nanoscale materials. In this topic we will cover properties and application of carbon nanotubes, fullerenes and graphenes. Nanoscale materials. Nanoscale material belong to a unique family of compounds that forms a bridge molecule and condensed layer. Nanomaterial findings are the application in field of medical diagnostics, healthcare, environmental remediation, high density data storage, etc. Nanomaterial have change in physiochemical properties such as band gap, melting point, magnetic property and specific heat with size and shape. First one, carbon nanotubes, that is CNT. Carbon nanotubes are allotropes of carbon with a nanostructure having a length to diameter ratio greater than 1 crore. Properties. First one, strength. Carbon nanotubes are the strongest, flexible, stiffest material yet discovered in terms of tensile strength and elastic modulus respectively. Second point is hardness. The hardness, that is 152 GPa, and the bulk modulus, that is 462 to 546 GPa of carbon nanotubes are greater than the diamond, which is considered as the hardest material. Third point is electrical properties. Because of the symmetry and unique electronic structure of graphene, nanotube has a very high current carrying capacity. Fourth point is thermal conductivity. All nanotubes are expected to very good thermal conductors along with the tube. Fifth point is EM wave absorption. There has been some research on filling MWNTs with metal such as iron, nickel, cobalt, etc. to increases the absorption effectiveness of MWNTs in the microwaves regimen. Sixth point is thermal properties. All nanotubes are expected to very good thermal conductors along with the tube, but the good insulators laterally to the tube axis. Applications. First one, CNTs are used as an electrode material for a lithium-ion rechargeable batteries. Second one is CNTs used in a field emission of X-ray tubes. Third one is CNTs are used in a cancer thermotherapy to selectively kill the cancer cell without affecting nearby healthy tissues. Fourth one is CNTs are used as a electrode material in a microbial fuel cell, that is MFC, for water purification. Next move on to the fullerenes. Fullerenes are allotropes of carbon. Fullerene exists in the form of sphere, ellipsoid tube and many other shape. Spherical fullerenes is also called buckyballs and they resemble the balls used in a football, that is saucer. Properties. First property is chemical reactivity. Under that, aromaticity. It will be display aromatic properties if the 2n plus 1 the whole square rule where n is integer is satisfied. C60 is non-aromatic. Fullerenes are insoluble in polar solvent but are soluble in aromatic solvent and carbon disulfide. It has a high electron affinity and it is reactive chemically, especially with a free radical. Rapidly decomposes in the presence of light and trace amount of ozone in the air. In pure oxygen, C60 begins to sublimate at 350 degrees Celsius and ignited at the 365 degrees Celsius in air, it oxidizes rapidly to carbon monoxide and carbon dioxide. Physical properties. First one, insoluble in water. Second one, it cannot conduct electricity. Third one, soft and slippery. Fourth one, brittle. And last one, low melting point. Applications. First one, medicinal application of fullerene are: first one as antioxidant, second one antimicrobial agent, third one drug delivery, and last one photosensitizers in photodynamic therapy. Some other applications are: first one as personal care products, second one as dry lubricants in coating application, third one in solar cell, fourth one in hydrogen gas storage, fifth one as strengthening or hardening of metals, sixth one as sensors, seventh one as organic photovoltaic, eighth one as catalyst, and last one in water purification and biohazard protection. Next move on to graphenes. Graphenes can be described as a one atom thick layer of graphite. It is a basic structural element of other allotropes including graphite, charcoal, carbon nanotubes and fullerenes. Graphene is the strongest, thinnest material is known to exist. Properties. First one, chemical properties. Graphene is chemically the most reactive form of carbon. only form of a carbon in which each single atom is in exposure for chemical reaction from two sides. Carbon atom at the edge of the graphene sheet have special chemical reactivity. Graphene burns at very low temperature. Second one is electronic properties. It is a zero overlap semi-metal with very high electrical conductivity. Electrons are able to flow through graphene more easily than through even copper. Third one is mechanical property. To calculate the strength of graphene, scientists used a technique is called atomic force microscopy. It was found that graphene is harder than diamond and about 300 times harder than steel. The tensile strength of graphene exceeds 1 TPa. Fourth one is thermal property. Graphene is a perfect thermal conductor. Its thermal conductivity is much higher than all the other carbon structures as carbon nanotubes, graphite and diamond. Graphite, the 3D version of a graphene, show a thermal conductivity about 5 times smaller. The ballistic thermal conductance of graphene is isotropic, that is, small in all directions. Fifth one is optical properties. Graphene, despite its only one atom thick, and it is still visible to the naked eye. Due to the unique electronic property, it absorbs a high 2.3% of light that passes through it. Application. First one, biomedical. Graphene could soon be used to analyze DNA at record-breaking pace. Second one is energy storage devices. Due to the extreme high surface area to the mass ratio of graphene, one potential application is in conductive plates of the supercapacitors. It is believed that graphene could be used to produce supercapacitor with greater energy storage density than it is currently available. Third one is solar cell. Graphene turned to be promising material for electrochemical energy conversion in dye-sensitized solar cell. The transparent conductive and ultra-thin graphene film are fabricated from exfoliated graphite oxide followed by thermal reduction. Fourth one is filters. The graphene filters are used in a desalination and ethanol distillation. Fifth one is integrated circuit. Graphene has a high carrier mobility as well as low noise, allowing to used to the channel in the field effect transistor. Sixth one is antibacterial. Graphene oxide are highly effective at killing bacteria such as E. coli. Seventh one is optical electronics. Graphene's high electrical conductivity and high optical transparency make it a candidate for transparent conducting electrodes. Other applications are graphene nanoribbons, IR detectors, single molecule gas detection, piezoelectric materials, energy harvesting, composite material, liquid cell for electron microscopy, thermal management material, optical modulators and chemical sensors. These are regarding nanoscale material. Thank you.
Wow, that's impressive! You have completed a magic today. For more videos, subscribe. Join our Facebook group and Instagram page for group discussion and live magazine videos for exam preparation in an hour. We start at ClassFly community for students to learn from a friend in a simple way and support them in their own languages. If you are willing to be that one friend who saves us at the exam night preparation, then please join us by visiting classfly.in.